In this video, we're going to focus on two very helpful and handy alternative multiplication algorithms. The first one is called lattice multiplication. And what you do is you set up the product. So we're looking at the product of 28 and 47. So 28 times 47. And you write that on the top and the right-hand side of a lattice, which is a grid. It's basically a 2 by 2 table with the diagonals. What you do in lattice multiplication is you say you multiply each digit. Don't worry about the place values. Just say 4 times 8. The top part of the lattice is the tens, so that is 3 tens and 2 ones, or 32. Then you go down and look at, so just fill in all the grids in the lattice. 7 times 8 is 56, 5 tens and 6 ones. 4 times 2 is 0 tens, that's 8, right? 0 tens and 8 ones. And then 7 times 2 is 14, which is 1 10 and 4 ones. So you fill in each grid just multiplying the digits around the lattice. Then what you do is you add along the diagonals. So just add along those diagonals. And we're in base 10, so we'll add in base 10. So 6 plus 6 plus 0 rather, is nothing, so 6 is just 6. Then we add along this second diagonal. 2 plus 5 is 7, plus 4 makes 11, that is 1, and I'm going to carry 1 over to the next grid, the next diagonal. 1 and 3 is 4, 4 and 8 is 12, 12 and 1 is 13, that is 3. And we'll carry 1 to the next diagonal. So it's just like adding, you just are carrying it to the next diagonal. 1 and 0 makes 1. So that says that 28 times 47 is 1316. I can't tell you how many times when I've taught this topic, people will say, why didn't we learn that when I was in elementary school? There's very little record keeping going on, and actually very little carrying that's needed. So let's do a little larger example. We're going to look at the second product of 4,527 times 36. So that's the product, 4,527 times 36. You might sort of kind of roll your eyes and say, oh my gosh, I would not want to do that via a standard approach. Let's see what happens with the lattice multiplication. 6 times 7 is 42, 4 tens and 2 ones. 3 times 7 is 21. I'll just do the top row, I guess. 3 times 2 is 0 tens and 6 ones. 3 times 5 is 15. 3 times 4 is 12. Let's go down to the second row. 6 times 2 is 12. 6 times 5 is 30. 3 tens and 0 ones. 6 times 4 is 24. So we filled out each grid, just multiplying the digits. Now add along the diagonals. So 2 and nothing, so 2 is just 2. 1 and 4 and 2 makes 7. 2 and 6 is 8, and 1 makes 9. 5 and 3 makes 8, and 4, that makes 12. So this is where we need to do a little carrying here. So that's going to be 2, and carry 1 into the next diagonal, because remember our diagonals are kind of like our columns in the traditional algorithm. 1 and 1 is 2, and 4 makes 6, and then along this last diagonal you just have 1. So very quickly we can see that 4,527 times 36 is equal to, just read along the side, 162,972. All right, the second alternative algorithm is one that I don't know don't ask me where the name came from. It's called the Russian peasant algorithm. I don't know if they discovered, actually there's a branch of mathematics called ethnomathematics where individuals study how people use mathematics in other cultures. I'm not sure if that's where this came from, but that's the name. I didn't make it up. That's just what the name is. But a lot of people call it the halving and doubling algorithm. So what you do is, in this case, I'm going to find the product of 42 times 47. So what I'm going to do is I'm going to halve not have, but halve, H-A-L-V-E, cut in half the values in the first column, and I'm going to double the values in the second column. Okay, so when I cut this in half, so divide it by 2. So 42 divided by 2 is 21. So I'm going to halve that column, and then double the next column. 47 times 2. So essentially, you divide by 2 in the halving column, and you times by 2 in the doubling column. 47 times 2 is 94. All right. Now, this is where it's a little trickery, if you will. 21, when you have it, you get 10.5. You have to ignore the remainders. So 21 divided by 2 is 10.5. Ignore that remainder. So I'm just having 10. 94 times 2, again, you have to double this column. 94 times 2 is 188. Have, there you go, the 10, that becomes 5. When I double the next column, that's going to be 188 times 2. I need to just use my calculator. I think it's 360, 376. Just double check. 376. Now we've got to have the 5. Again, 5 divided by 2 is 2.5. You've got to ignore the remainder. Okay, so in other words, you omit the remainder, which occurs when you're actually having the odd values. So 5 divided by 2 is 2.5, so I'm just left with 2. 376 times 2 is 752. Having and doubling. Finally, I have the 2. 2 divided by 2 is 1. That's when you end. When you get down, when the have column gets down to 1. Multiply the doubling column again. So 252 times 752 times 2 is 1504. So have and double. Now what you do is cross out any of these halving columns. In the half columns, find the even ones. So 42 is even, so I'm going to cross out that whole row. 21 is odd, that's okay. 10 is even, I'm going to cross out that whole row. 5 is odd, I'm going to keep it. 2 is even, I'm going to cross out that whole row. Okay, so have, double, cross out the even rows. So the rows where in the have column, if you have the have column, the even halves. Now, what you need to do is just add up the remaining values in the double column. You've got 94 plus 376 plus 1504. So when I add those up, I get 94 plus 376 plus 1504. And that equals 1974. Now, let's go and can go to your calculator or do this via any algorithm that you choose. 42 times 27, or times 47, excuse me, just to check, is also 1974. So, through halving and doubling, we can come up with a product of 42 times 47.